Alright, y'all. It's another LeetCode Let's Play video. Um, so let's solve this coding problem. So we're given heads of two sorted linked lists. Okay. Uh, merge the two lists, one sorted list. Merge the two lists into one sorted list. Okay. By splicing together the nodes of the first two lists. Return the head of the merged linked list. Okay. So let's think about this. Okay. So I'm gonna make a pre-head. What is it? What's the object called? This node? Where's the object? I'm trying to figure out. Okay, whatever. Then we need a previous, which will be set to prehead. So then we need to loop through the entire list because we can't index arrays. So we'll do while and L2 exist. We're going to say if L1.value let me print out what the list is. Okay. So val next, okay. And it is list node. Perfect. So if L1.value is less than or equal to L2.value, what we're going to do is say L1, we're going to have to go L1 equals L1 to next, traverse. And then we're going to say previous dot next equals L1. Otherwise, so we're checking to see if the value is less than. If it is, we get our head and we say, okay, well the next, in this case, so prev.next, which would be the head, its value is going to equal whatever the lesser value is. So we're adding the smallest to the front. Then we're going to say otherwise, we're going to set previous.next equal to L2, then L2.next, or L2 equals L2.next. And then we're going to set previous equal to previous.next because we need to traverse. And then we're going to send the head of the head of the prehead. So we're going to return bro prehead.next. That'll return the head. Okay. Okay. So that's happening because one list is ending before the other. How can we fix that? We can add we can do a ternary operation. We can say, ooh, how would we do that? Okay, so we know previous. Previous.next equals L1 if L1 not none or L2. I don't know if that's right. So L1. There we go. All right. Yeah, that solves that. Let's try some other usage cases. It's another one. Yep. There we go. List must be non-decreasing. What does that even mean, bro? 1, 2, 4. Okay. Bro, are you kidding me? 1, 3, 4, 1, 5, 3. Oh, 5, 8, 98, 30. There you go. Alright, we passed all the test cases. And that's the algorithm, y'all. Essentially all we did was we got the head of the, well, I had to print out to see what the list looked like. But we created a new head with the value of -1 just to start. Now what we did then was we said, okay, well the previous is going to be, we're starting at pre-head, so we're going to say the previous is going to be the before the list actually starts. So then once we do that, we say, okay, well if the previous value, so we're basically starting a new head by doing this. And then we're saying while L1 and L2 are not none, so there is a value, we say L1 value is less than L2 value. And we say, well, let's get the previous next. We're going to set that equal to if it's less than or equal to L2, meaning if this is less than that, if a 6 is less than 9, then we basically set the next previous, so the one before, will be set to that. So for instance, if we had 9 and 21 here, if 21 was here, we'd say, okay, well, the next previous would be here, so we'd swap it over, which would be 9. And essentially, if we look at our test cases, we'd say, well, if 1 is going to be the smallest, then we'd run our operation to say, okay, well, if 5, we go move to the next one, we'd say, okay, well, is 6 less than 5? Is 6 less than 1? No, it's not, so we keep it. We append it there, right? Then we say, okay, well, into our new list. Then we say our new list starting at head, pre-head. Then we say, okay, well, if 6 is 5 less than 6? Yeah, it is. So what we're going to do is we're going to replace the previous, which is 6, is to the next, and then we're going to traverse to the next on the new essentially the new chain that we created off of prehead, as I mentioned, and we'll continue along that, doing that pattern of checking to see if it's less than. Otherwise, we're going to set it and just append it to the end of the list without really, because it's obviously greater than if it's not less than or equal to, meaning it'll be pushed to the end of the array. And then otherwise we say, okay, well, if the previous.next, we set the last, because the previous, remember, is the last, and this will take the the tail end of the linked list. We'll say, okay, well, if the next one is, we can assume that the last one is going to be, we're going to be missing an index because one, just to make sure if one list is greater than the other. We say, well, if L1 is none, so if L1 is not none, then we go ahead and set it equal to L1, to the last list index, the last node. Otherwise, we set it equal to L2.next, which remember we set L2 to the next node, so the ending. And then we return the head and .next. Now if we return this, it's not going to work because the starting index is -1. But if we return the next, we'll start at the actual head. Because remember, we started a new linked list by doing this. And we put a negative number just to keep, to make sure that the value is going to be less than. Because we are assuming that it's less than. Now we can make this -90. And it would still work. Because -1 is greater than -90, so it'd be appended to the previous. It wouldn't be appended to the previous, it'd just be added.